There is a wall in Peru that engineers cannot explain. Not cannot explain in the way that people say something is complicated. Cannot explain in the way that, when serious structural engineers stand in front of it, they go quiet. The wall is made from stone blocks. Some of them weigh more than 100 tons. A few of the largest weigh close to 130. They were quarried from outcrops more than 35 kilometers away, dragged across mountain terrain, hauled uphill, and fitted together stone against stone, surface against surface, with no mortar, no cement, no bonding agent of any kind. And the joints between them are so precise that you cannot slide a sheet of paper through them. After more than 500 years of Andean earthquakes, not one of those stones has shifted. The site is called Sacsayhuaman. It sits on a ridge 400 meters above the ancient Inca city of Cusco, in the high Peruvian Andes, at an elevation of nearly 3,700 meters. That is over 12,000 feet above sea level. Today, we are going to spend the next 30 minutes walking through everything we know about this place and everything we do not. Because the honest truth is that recent discoveries, some of them made just weeks ago in April of 2026, have transformed this from a well-known ancient mystery into something that may be genuinely larger than anyone realized. So get comfortable, turn up the volume, and let us start at the beginning. Before we go any further, I want to tell you one thing. Because it is easy to hear about ancient stonework and think, yes, impressive old buildings, I have seen documentaries about this. The soldiers who conquered Peru in 1532 were not easily impressed. These were men who had crossed the Atlantic Ocean, men who had toppled the Aztec Empire, hardened, experienced, ruthless men. When they first stood at the base of these walls, they wrote in their official chronicles that the stones must have been placed by demons, that no human hands could have done this. Now, they were wrong to say that. Human hands absolutely built this place, we know that much. But the question of how those human hands achieved what they achieved is one that modern engineering has not yet answered to anyone's satisfaction. And the weight and the size, as extraordinary as those are not even the hardest part of the problem. The hardest part is the precision. And that is where we are going today. To understand what we are looking at, we need to understand who the Inca were and what the official explanation says about how they built. The Inca Empire, known as Tawantinsuyu, the four quarters of the world, was one of the largest empires in human history. At its peak in the early 16th century, it stretched over 4,000 miles along the western coast of South America, from what is now southern Colombia, down through Ecuador, Peru, Bolivia, and into Argentina and Chile. It contained millions of people, hundreds of distinct cultures, and one of the most sophisticated road networks ever constructed anywhere on Earth. Over 40,000 kilometers of roads crossing deserts, jungles, and mountain passes maintained by a centralized administration that managed labor, food, and trade on a continental scale. The Inca were extraordinary organizers. They ran their empire without money. Instead, they used a system called mita, a form of labor taxation where every family owed the state a period of work each year. In return, the state fed them, housed them, and clothed them during their service. That system is how Sacsayhuaman was built. Spanish chronicler Pedro Cieza de Len, writing in the 16th century from accounts he gathered from people who had participated in the construction, recorded that at the height of the project, 20,000 workers were laboring on the site at once. Construction began under the great Inca ruler Pachacuti, considered the founder of the imperial Inca state in the mid-15th century. It continued under his successors and is thought to have taken nearly 100 years to complete. And here is the official explanation for how those stones were cut and moved. Stone hammers made from harder rock diorite and granite used to chip and peck away at the softer andesite and limestone. Bronze chisels for finer work. Thick ropes made from plant fibers, timber sledges placed under the stones, and enormous teams of workers hauling in coordinated shifts. That explanation is not wrong. Archaeologists have found the tools. They have found the ropes. They have found the earthen ramps. Spanish eyewitnesses watched workers using exactly those methods. But here is where the story gets complicated. Because those methods, the ones we know were used, can account for some of what we see at Sacsayhuaman, they cannot account for all of it. The site that stands today represents roughly 40% of what was originally constructed. The Spanish dismantled the rest using Sacsayhuaman as a stone quarry for their colonial buildings throughout the 16th century. What remains are 3 massive zigzag terrace walls, one above the other, running roughly 550 meters from east to west. The zigzag pattern is not decorative. It serves a military purpose. Anyone approaching the walls head-on is exposed to fire from multiple angles simultaneously. It is sophisticated defensive geometry, but what stops visitors in their tracks is not the layout, it is the individual stones. Each block is what architects call polygonal. That means irregular, not a simple rectangle, not a cube. Each stone has somewhere between 6 and 20 separate faces, angled, sloped, sometimes curved, and every single one of those faces fits perfectly against the faces of the neighboring stones. The blocks interlock in 3 dimensions, like a jigsaw puzzle made from boulders. The largest single stone at Sacsayhuaman stands over 8 meters tall, that is 26 feet, and weighs approximately 125 to 130 metric tons. That is heavier than 2 fully loaded passenger aircraft, and it sits in the lower terrace as if it were placed there yesterday. Now here is the engineering insight that most people miss. The polygonal, irregular shape of the stones is not a primitive feature. It is not the Inca doing their best without proper tools. It is a deliberate structural strategy. When an earthquake strikes, and they strike frequently in this part of Peru, sometimes violently, a wall built from rectangular blocks held together by mortar will crack at the joints and collapse. The mortar bonds, and the bonds fail, but a wall built from interlocking polygonal stones, with no mortar, during an earthquake, the individual stones flex and shift, slightly absorbing and distributing the energy, and then they settle back. The absence of mortar is not a limitation. It is the solution. Every Spanish building the conquistadors constructed on top of Inca foundations has cracked, shifted, or required rebuilding over the centuries. The Inca walls beneath them have not moved. Here is a question I want you to think about while we continue, and I want you to leave your answer in the comments below, because we read every single one. Looking at those walls, those irregular, interlocking stones fitted together without a single formula or blueprint that we know of, do you think the achievement is explained entirely by patience and skilled labor? Or does it point to something we have not yet found the evidence for? Let us know below. Moving the stones is a separate problem from cutting them, and the movement problem is severe. The primary quarry for the andesite used in Sacsayhuaman's Great Terrace walls is called Rumicolca. It sits approximately 35 kilometers southeast of Cusco, about 22 miles, and the terrain between the quarry and the construction site is not flat. It involves river valleys, slopes, and a final uphill haul to the ridge where the complex sits. Archaeological evidence shows clearly that the Inca used timber sledges, rollers, ropes, and the coordinated muscle of thousands of workers to move these stones. That is not in dispute. Spanish eyewitnesses documented it. But here is the engineering reality. Modern experiments have shown that a team of about 100 workers can move a stone weighing roughly 10 to 15 tons, using timber rollers and rope across relatively flat ground. Scale that up to a 100-ton block, 10 times the weight, and you are looking at an exponential increase in difficulty. The ropes become the limiting factor. The ropes of the ancient world simply broke under loads that large. Researchers have proposed that the Inca used a different technique for the heaviest stones, a process of rocking the block forward in short increments using levers rather than dragging it. There is some experimental support for this. It is plausible, but no one has demonstrated it works for blocks in the 100-ton range. Across 35 kilometers of Andean terrain, up to an elevation of 3,700 meters, without modern equipment. And then there are the stones that never made it. In the quarry at Rumicolca, and at secondary quarry sites closer to the complex, there are unfinished blocks, partially extracted, still attached to the bedrock in some places, abandoned mid-work. One of these abandoned stones has been measured and analyzed. It was clearly being shaped and prepared for transport. and then the work simply stopped. No one came back. We do not know why. A natural disaster, the death of a ruler, the approaching Spanish. Something interrupted the project in a way that was never recovered from. But those abandoned stones tell us something important. They show us what the work looked like in progress, and they show us that the scale of what was planned at Sacsayhuaman was even larger than what was completed. The builders were not finished when history intervened. Moving the stones is hard to explain, but cutting them with the precision we see is harder. Sacsayhuaman's walls are built primarily from andesite, a dark, dense volcanic rock. Andesite has a hardness rating of about 6 on the Mohs scale. To give you a reference point, a steel knife blade is about 5.5. The cutting tools we know the Inca possessed were stone hammers typically made from diorite, which is harder than andesite and can therefore chip it, and bronze chisels. The process is called rock pecking. You strike the stone surface thousands of times with a harder stone, slowly abrading it into shape. For limestone and softer rocks, this works well. Experimental archaeologists have used this technique successfully to reproduce Inca stonework in softer materials. But andesite is harder, and the harder the stone, the slower and more labor-intensive the process becomes. And the precision required at Sacsayhuaman is not rough or approximate. These surfaces are flat to within millimeters. These angles are exact. These joints hold without mortar after 5 centuries of seismic activity. Experimental archaeology programs have attempted to replicate the joint quality seen at Sacsayhuaman using only the tools available to the Inca. The results are instructive. Skilled modern stonecutters, using diorite hammers and time, can produce impressive work. The surfaces get close, but the extraordinary consistency of fit across hundreds of stones, each one uniquely shaped with a dozen or more angled faces, achieving that through stone-on-stone pecking alone, has not been convincingly replicated. Now, this does not mean it is impossible. It means we have not worked out the full sequence of techniques. Perhaps there was a final fitting process we have not identified, a method of refinishing the stone at the construction site after transport that achieved the final precision. Some researchers have proposed exactly this, based on tool marks visible on certain stones that suggest reworking after placement. Others have noted that some stone surfaces at Sacsayhuaman show markings that are not consistent with hand-pecking markings that look more like scoring from a harder edge, moved in a controlled, consistent way. These markings have not been satisfactorily attributed to any known ancient tool. The honest position of current archaeology is this: we know the general method. We do not yet know the complete method, and the gap between those two things is where the mystery lives. Sacsayhuaman is not just what you can see. There is an entire world beneath it. For centuries, local oral tradition in Cusco has spoken of the Chincana, a network of underground tunnels running beneath the hill. In Quechua, the language of the Inca, Chincana means labyrinth, a place where one gets lost. Colonial-era Spanish chroniclers in the 16th, 17th, and 18th centuries recorded accounts of these tunnels. Some described them as connecting Sacsayhuaman to the great Inca temple in Cusco, below the Coricancha, the Temple of the Sun. Others described chambers and vaults containing offerings, mummies, and treasures. There were stories of people entering the tunnels and never returning. For generations, archaeologists treated these accounts with skepticism, oral tradition, and colonial-era speculation. Then, in 2024 and 2025, the Chincana Sacsayhuaman project, a formal archaeological investigation led by Peruvian archaeologists Jorge Calero Flores and Mildred Fernandez Palomino, used ground-penetrating radar and acoustic perspection to map what lay beneath the hill. They found the tunnels. The primary tunnel system extends 1,750 meters, that is nearly a mile, at a depth of between 1.4 and 2.5 meters below the surface. Branch tunnels connect to additional structures. The network may extend for more than 8,000 meters in total. That is 5 miles of underground passages, stone-built, deliberately constructed, running beneath one of the most studied ancient sites on Earth. The findings align with the historical documents. The tunnels appear to connect Sacsayhuaman to sites below in the city precisely as the oral tradition described. Active archaeological work is now underway. Entrances have been opened and documented. The contents what the tunnels actually hold are only beginning to be revealed. This investigation is ongoing. As of the time we are recording this video, what we can say is this: the builders of Sacsayhuaman did not just build what you can see on the surface, they built beneath it as well. The site is, in every sense, larger than it looks. In April of 2026, just weeks before we recorded this video, a team of Italian and Polish researchers published findings that have fundamentally changed how we understand the scale of what was built at Sacsayhuaman. The team is from the Italian National Research Council's Institute of Cultural Heritage Sciences, known as the Ithaca Mission, working within an international project called The Origins of the Capital of the Incas, coordinated by archaeologist Aleksiej Wronek of the University of Warsaw. They used drone-mounted LiDAR laser scanning technology that can penetrate through dense vegetation to reveal the topography of the ground beneath, and they applied it across a study area of 69 hectares around the Sacsayhuaman complex. LiDAR works by firing millions of laser pulses per second downward from the drone. The pulses bounce back at different times, depending on what they hit: leaves, branches, soil, stone. A computer processes the returns and strips away the vegetation, leaving a precise three-dimensional map of the ground surface. What they found was startling. Beneath the vegetation, invisible to ground-level observers for centuries, is a dense network of agricultural and retaining terraces, extending far beyond the boundaries of the visitable park. There are traces of a secondary road system connecting different sectors of the hill to the valley below. There are what appear to be architectural structures, walls, platforms, enclosures that were never known to exist because they were never visible. The research team's conclusion is direct. The area surrounding Sacsayhuaman was far from being an empty space. The entire hillside was organized, built, and connected, an urban system of which the famous zigzag walls are only the most visible surviving element. The subsoil, they wrote, contains an archaeological archive far more complex than traditional historiography had assumed. In plain terms, we have been looking at Sacsayhuaman for 500 years and thinking we understood its scale. We were wrong. The site is much, much larger, and the vast majority of it has never been excavated. This is not a fringe claim. This is a peer-reviewed finding from a funded international research program using the most rigorous, non-invasive technology available. It changes the picture. There is one more dimension to Sacsayhuaman that does not get enough attention, and it begins with the shape of the city below it. The city of Cusco was deliberately designed in the shape of a puma, the mountain lion sacred to the Inca. This is not legend. It is documented in colonial-era accounts and confirmed by the layout of the structures. The body of the puma forms the central ceremonial district. The tail is the confluence of the two rivers, and the head of the puma is Sacsayhuaman. The zigzag walls represent the teeth. This tells us that Sacsayhuaman was not designed independently from the city below. It was part of a unified sacred geography, a deliberate symbolic landscape, planned on a scale that required coordinating the placement of buildings across an entire urban area. And then, there is the sky. The orientation of Sacsayhuaman's main walls is not random. Like the great megalithic sites of Europe and Egypt, Sacsayhuaman is aligned to the movements of the sun. Specific sections of the walls align to the sunrise at the June solstice, which in the southern hemisphere marks the winter solstice, the shortest day of the year, the most important astronomical moment in the Inca calendar. The great festival of Inti Raymi, the festival of the sun, was held at Sacsayhuaman every year at the winter solstice. The Inca emperor himself would attend. Thousands would gather. The site was not merely functional, it was cosmological. This pattern, massive stone construction, extraordinary precision, astronomical alignment appears not just here, but at Stonehenge in England, at the pyramids of Giza, at Göbekli Tepe in Turkey, at Baalbek in Lebanon. Cultures separated by thousands of miles, and supposedly by thousands of years of disconnected history, all building in ways that encode their understanding of the sky into the very geometry of their structures. We are not suggesting a single lost civilization built all of them. We are observing that something about the human relationship to stone, to scale, and to the movements of the sun and stars seems to have independently produced very similar impulses in very different cultures, and we do not yet fully understand why. So let us be direct about what we actually know, what remains genuinely uncertain, and what the honest answer looks like. What we know for certain: the Inca built Sacsayhuaman. This is not seriously disputed. Pachacuti ordered the construction in the mid-15th century. His successors continued it. The Mita labor system brought 20,000 workers to the site at its peak. Construction continued for nearly 100 years. Spanish eyewitnesses saw Inca workers moving stones using timber sledges, ropes, and human power. Archaeological artifacts, tools, pottery, human remains confirm sustained Inca presence and activity throughout the site. The Inca were extraordinary engineers. Do not let the mystery of the precision blind you to the reality of what organized, intelligent, and determined human effort can achieve. They built the road network of the Andes. They built Machu Picchu. They built hundreds of precision stone structures across thousands of kilometers of mountain terrain. They knew what they were doing. What remains genuinely unsolved: the full sequence of techniques used to achieve the precision of the joints in the hardest stones has not been convincingly replicated. Using the tools we know the Inca possessed, experimental archaeology has gotten close with softer stones. It has not gotten there with the hardest. How the heaviest blocks in the 100 to 130-ton range were transported 35 kilometers through mountain terrain remains incompletely explained. Plausible methods exist. They have not been demonstrated at this scale. The full extent of the site, now dramatically expanded by the April 2026 LiDAR survey, has never been excavated. The Chincana tunnel network is only beginning to be investigated. We do not know what is under there, what some researchers believe, and what the evidence cannot yet confirm. There is a body of research suggesting that some of the stonework at Sacsayhuaman, particularly the most precisely fitted lower sections, may predate the Inca and belong to an earlier culture. The Inca themselves, according to Spanish chronicles, claimed that some of the great stones were already ancient when their civilization rose to power. These claims are taken seriously by some archaeologists and dismissed by others. The evidence is not yet sufficient to resolve the question. What we can say is that the question is legitimate, and that the 2026 LiDAR findings, revealing a far larger and more complex site than previously understood, have made the question more urgent, not less. The honest answer is this: the people who built Sacsayhuaman were remarkable. The full story of how they did it is not yet complete, and the site that we thought we understood is still revealing itself.